The next topic is force, magnetic force on a current carrying conductor. On a current carrying conductor. Lecture 2. For this purpose is we see that if there is a magnetic field and a charged particle is thrown at right angle to the field, that charged particle will experience a force, and the magnitude of that force is given by F is equal to Q into V cross B. Q into V cross B, the magnitude of that force will be. If the charged particle is thrown parallel to the magnetic field, then it will experience no force at all. Why we are throwing the charged particle at right angle? To get a maximum force. Here you see the charged particle depend upon the speed is velocity as well as the magnetic field. If it is parallel, means if the angle between V and B is 0, then you will have no force at all. If it is at right angle, then you will have a maximum force. For that purpose, we have a magnetic force on a current carrying conductor. If a conductor is free of current, then if it is placed in the magnetic field, then it will experience no force. From the topic you see that if there is a wire and that wire is carrying a current, if it is placed in the magnetic field, then that wire will experience a force. And you see that the magnitude of that force depend upon the amount of current, length of the conductor, as well as the magnetic induction. So for that purpose, we are taking a conducting wire of length dl, area of cross section is A. This is a conducting wire having area of cross section A, and let I be the amount of current flowing through this conductor. The wire is placed along x-axis, here you see in this way, while the magnetic field is applied perpendicular to it, that is at right angle to the length of the wire will experience a force. This wire will experience a force due to the magnetic field. How? You see that there is interaction between the two fields. One is already taken, external field, and the second field is due to the current which is in the conductor. Due to the interaction of the two fields, there is a force, and that force is perpendicular to length of conductor and magnetic field. Means this force is perpendicular to the plane of the conductor carrying current as well as the magnetic field. And the magnitude of that force is determined as follows. Let n be the number of charged particle per unit time of a conductor which causes flow of current. For example, this is a conductor and you have n number of charged particle, and the area of the conductor is A, and the length of this conductor is dl. Then the total number of charged particle in a conductor is Na, volume is NaDl, where A is the area, D is the length element in this case, and N is the number of charges. If each charge carries Q amount of charge, then in here, if the speed is V draft, then force on each particle is equal to Q into V cross P. Means the magnitude of this is the force on a single charge particle if it is placed perpendicular to the field. Total force on all particles that is force on conductor is given by dF is equal to Q in A dl into Vd cross B, or the magnitude of this force will be equal to Na dlq into Vd cross B. Is Vd is perpendicular to B, so dF in this case will be equal to Na dl q Vd B sine 90 degree, and this will become Na dl q Vdb. This is the magnitude of force. But we know that J is equal to QNVD, current density, यानी EVD के बराबर है। अगर आपके पास n नंबर ऑफ चार्जेस हों तो आपके पास जो करंट डेंसिटी है वो आ जाएगा इस J is equal to QNVD. This is the value of J current density. So dF will be equal to JA dLB, or this will be equal to I dLB, is J is equal to I, क्योंकि करंट डेंसिटी J ये करंट पर यूनिट एरिया के बराबर है। किस चीज़ के बराबर है? करंट पर यूनिट एरिया। सो डी एफ जो है आपके पास आ जाएगा आई डी एल क्रॉस बी। अगर आप इसको वेक्टर फॉर्म में लिखना चाहें now how much will be the total force? Total force is obtained by integrating I dl cross b. This will be the force on a wire carrying current and uniform magnetic field. As you see that just we see that if there is a charge, if that charge is thrown in a magnetic field, that charge experiences a force, and the magnitude of that force is given by QV cross B. Similarly, if there is a wire carrying current and that wire is placed in external field, then that wire will experience a force, and the magnitude of that force will be given by I into L cross B. This will be the magnitude of force. Here L is a vector quantity. L is a vector quantity. The length of the wire shows its magnitude, while the current flow shows its direction. यानी लेंथ जो है that is स्केलर क्वांटिटी, लेकिन यहाँ लेंथ जो है L ये वेक्टर क्वांटिटी है। इस वायर की जो लेंथ है वो इसका मैग्नीट्यूड होगा, और इस वायर का जो डायरेक्शन है, इस करंट का जो डायरेक्शन है वायर में, वो उसका क्या होगा? डायरेक्शन होगा लेंथ का। तो गोया ये आप देख रहे हैं कि L क्रॉस B, एल बी साइन थीटा है। अगर वायर को पैरेलल टू द फील्ड रखें तो that will experience no force at all. If it is placed perpendicular to the field, that will experience a maximum force. If the current is switched off, again the force will be zero. although if you have been placed the wire in the field, but if the wire carries no current, then you will not get any force, and the magnetic field of force will be 0.